So this question is 78 subset. So this question is given an integer array nums of unique elements. Return all of possible subset. So this solution may not contain any duplicate subset. So the solution is backtracking because we have to find all of the combination for this. So how do we solve it? So first we have subset, right? And this is our remain. So what is backtracking exactly? So we have to make a choice, and then we have to keep backtracking. Then the final step, we have to remove our choice. So in this example, we might have 1, 2, 3. So this bench we choose 1. So the remain is 2 and 3, right? So this I choose 2. And this I choose 3. And this I choose 3. And then this bench, first I pick 2. So remain is 1 and 3. So this I choose 1, 2, and 1. So what happened? So from this and this we found actually it is same subset, right? But we cannot return the duplicate subset. So how can we solve it? So this is the concept for the star index. So how does it work? So the star index is that after we sort it, we sort the nums. So if we pick 1, so remain is 2 and 3, right? So after it, we would not take, like, this bench we pick 2. So this bench we pick 3. So the star index is that because this bench we pick 2, and after this bench we would not pick 2 anymore, because the star index, the rules is we have to find after its index. So because 3 is the last element in this nums array, so the only way we pick from this level will have 2 elements. So after we use the star index technique, the graph will be like this, and we will never use after the element. For example, the 1 and 2 and 2, we would not use 1 anymore because we use the star index at here and also here. So you will see this is our very first answer, the empty subset. Okay, so from this node, we will have a for loop. You could see as a node, and we would iterate. So this is the first level. And the same level, the star index would be the same. And the I index would be increased. So it is just like the for loop and the function we will see after this graph. And the second level is star index would be s equals 1. And why it is 1? Because here it is 0, and we continue recursion, the I will plus 1, and then continue we will plus 1. So the last level I equals 2. And then after that we would, from here, sorry, I missed a step. We will pop the 3. We will pop the 3, and then we will pop the 2 and here. And the star index will start from 0, and then continue recursion, and the I will be 2. And then pop the 3, and then we will got 2. and we found that all of the subsets start from 2. We all found the subset. So after that, we will pop 2, 2. So we'll put 3 here. Okay, so the start index will be 0, and I will be 2 because I is 1 here, and then it will need to plus 1. It is for loop, right? We will have to input our nums array, right? So this is our result to record our final answer. And what is our backtracking exactly? So first, we have to record every answer, every subset in the result, right? So we have to put our answer first. It is like a tree, pre-order, and every node is a subset. So the path and the start index. So in order, pre-order, we have to append the very first answer, and it is the deep copy. Okay. And if we do that, we could avoid miss another element. Yeah. So you could think every node as a for loop. And like, because from this we would like have every level we would have a for loop, and what is exactly order? Okay, so first we will get this right, and here, and here, and here, and then we will pop the 3. And then we will pop the 3 again, and here, and then back here. So after it, you will find all of the subset. So what is exactly about the for loop? So from the start index to our nums array. So in the general time, we will have a base case for the backtracking. But why don't we have the base case in this function? Because we want to collect all of the answer, so we don't have to add the stop condition as known as our base case. So make our choice, and this is pre-order. We would add our nums. Okay, and then we start. Continue our choice. And start index, because we cannot have duplicate elements, so we have to plus 1 to get the next element in the array. And then after that, we have to remove our choice. Okay, this is our recursion. So after that, call our recursion the path initialize as a empty array and start from 0. Okay, so what is the time complexity? Because every element we will have 2 choice, include or not include in each subset. So we will have 2 times n, and we have n elements. So this is our time complexity. And what is our space complexity? Okay, sorry, I missed that. We have to sort. We have to sort so we can get each element in order. So, sorry about that. So, this complexity is because every time we have to sort it is log n, and we have n elements, so this is n log n, and plus n log n multiple n plus n times n multiple n. So the final answer is heedless. So why the space complexity? Because there can be a maximum 2 times n subset, so we will have maximum depth of recursion is 2 times n. So the space complexity of the recursion stack is also 2 times n. So this is our final answer. Okay,